Up next, we welcome Abubakar Abid. He is a machine learning team lead at HuggingFace and has worked with the company since its acquisition of Gradio. Previously, he was the CEO and one of the founders of Gradio. He completed his PhD at Stanford at the intersection of machine learning and medicine. He is originally from Pakistan and enjoys reading, basketball, and calligraphy. Abubakar will be discussing how to build interactive machine learning demos fast. Over to you, Abubakar. Thank you so much for joining us.
Hi, everyone. I'm Abubakar Abid. I'm a machine learning engineering team lead at HuggingFace. And before joining HuggingFace, I started Gradio, which is an open source library to help you build machine learning applications. So today I'll be talking about my some of that work, how to use Gradio and the HuggingFace ecosystem to build machine learning applications fast. And why are we discussing this topic? Machine learning applications are really getting a lot of heat. So Mark Andreessen famously a decade ago said the software applications were eating the world. And now it looks like machine learning applications are eating the world. So this over here is Hugging Face Spaces, which is a kind of a repository for machine learning applications. And you'll see hundreds of machine learning applications. All of these, the ones that I'm showing, were built in the span of just a few days. And these machine learning applications, they cover a lot of different use cases. So things like art, search, education, entertainment, productivity, and even accessibility. So let me start by just showing a few cool things that people have built as machine learning applications. And we'll start with art, why not? So for example, this was a recent space that gained quite a bit of traction. This space or this demo, what it does is it allows you to automatically rotoscope images. In other words, convert images to hand-drawn versions. So you can see this with a picture of Elon Musk. You can put in your own image, and it'll generate kind of a hand-drawn version of it. Now, what's interesting here is that this is something that's very artistic, and a lot of people just tried it out because they wanted to kind of see their own images, or they wanted to put in images of their pets or whatever it may be. But also, this is something that that professionally this is done, and this is quite a time-consuming task. Autoscoping, automated rotoscoping of images is quite a time-consuming task. And now we actually have machine learning models that can do this effectively instantaneously. And so this opens up a lot of possibilities on how rotoscoping could be used in other use cases. And then, of course, it's also kind of just a kind of interesting to explore artistically. There are lots of other similar artistically focused machine learning models that people have built demos for, and many of these have gone viral. So one of these demos that we built one of these models that we built a demo around was called Anime GAN, and what it did was it took an image and it turned it into an anime style version of that image, or similarly a kind of a cartoonistic kind of version of that image. And what we found was people, again, were using it for all sorts of interesting, artistic exploration, putting images of themselves, generating new profile pictures, but also putting images of their household objects, seeing what those would get turned to. And what we found was that when the barrier to creating this kind of art was lowered, a lot of people were kind of using it for lots and lots of use cases that might have been hard to imagine without these kinds of tools. And this is one that just a couple of days ago that we had folks build a Pokemon GAN, so kind of a machine learning model to generate completely new kinds of Pokemons that didn't actually even exist. So you see all of these different use cases, and those are just kind of in the art space. We see a lot of people building machine learning tools that to improve productivity. And I kind of hinted upon this with the rotoscoping machine learning model, but you have all sorts of interesting models that are built, for example, to summarize news articles. You can imagine this being useful if people want to consume, summaries of what's happening, or generate summaries of newspaper articles or scientific papers and so on. Sometimes, there's so much content we can't really consume it all. But machine learning models like this one can help us filter through and get summaries of the kind of articles that we want to consume. And there are lots and lots of other machine learning models. I won't really even get into this. I mean, there's just kind of a breathtaking array of different kinds of applications that people have built. What I actually want to do is I want to go forward now and talk about, I think what is quite interesting from the from the perspective of who is actually using machine learning tools. And this, I think, very much parallels the usage of personal computing and other technologies in general, where oftentimes initially in kind of the early stages, it's very niche academics and hackers who are using, these, in this case, personal computers, but really any sort of technology. After that point, it comes so that there are specific dedicated professions that are using that kind of technology. In our case, maybe machine learning engineers or software engineers that were using machine learning. But now what's cool is that really anyone who can use a GUI or has connection, can use an internet browser, can use state-of-the-art machine learning demos and applications. And this is very cool. And I think this is going to really change, not just like who's actually using machine learning models, but it's going to change the type of machine learning models that are built. Because initially, oftentimes, many machine learning models that were built were designed for these kind of niche audiences, very professional use cases. But now that anyone can use a machine learning model, perhaps the specific use cases that are being designed for, being developed for, can change as well. And so that's quite exciting. And the other kind of piece of that as well is that we find that many machine learning models have these blind spots, have these biases that were hard to detect before. But now that we have bigger audiences that are using these machine learning models, we can test them, we can see them, we can detect these problems and fix them as well. So it's quite exciting. What I want to talk about now is how to actually build machine learning applications. And this is also quite, we're at a turning point here as well, because historically building machine learning applications has been very difficult. And the reason for that is because it's consisted of a lot of different steps with very different frameworks, toolkits. So for example, machine learning developers would train a model, and this would be done in Python typically. So using open source libraries like TensorFlow, PyTorch, HuggingFace, JAX, all these different libraries here. But then when you actually wanted to build an application that other people could use, you actually had to deploy the model, which involved learning a whole set of different technologies, Flask, Dockerization, web hosting. Oftentimes you wanted people to use your model that in a way that wasn't just simply calling APIs. You wanted to be able to actually build an interactive user interface for it. So they had to learn, web development, HTML, JavaScript, CSS. And then you also wanted to store data that was coming in through the model. So you need to know something about databases. So all sorts of different frameworks. And the other problem was that all of these were in different languages. And so you had to have a lot of you had to have a lot of expertise in a lot of different languages and frameworks, and that involved a lot of context switching, learning new technologies that frankly most machine learning developers were not that familiar with and comfortable with. So that's actually why we started Gradio a few years ago. We open sourced this library called Gradio, and the whole purpose was, let us allow machine learning developers to do all of these other steps, containerization, deployment, building an interactive GUI, storing incoming samples in a language that they were all already comfortable with, Python. And so what Gradio did was abstract all of these other things away: containerization, building a GUI, incoming samples. And what we've seen is that people have really taken off. That the Gradio library has more than 5,000 stars on GitHub, primarily because of its ease of use. And because everything was in Python, machine learning developers did not need to learn a new language. And in addition to that, they can run it wherever they're already running their Python code, whether it's the Python IDE, whether it's Jupyter notebooks, Colab notebooks, whatever it may be. So what does Gradio actually look like? Let's take a look at a very simple example here. So it's in Python. So this syntax should be familiar to anyone who uses Python. So the Gradio package is just import Gradio. So this assumes you've already pip installed it, but you can just import Gradio. Then you create a Gradio.interface class. So this class called interface, or short for user interface, is the key class in the Gradio package. And so what this allows you to do is this allows you to create a user interface around a machine learning model that you have, just by specifying a list of inputs and outputs. So in this case, my input here takes in an image, and the output is a label. Okay, and this just corresponds to what kind of model this is. Okay, what kind of model is it? It's a skin image classifier. So if you write this in Python, and again, it takes in 3 ingredients here. The first ingredient being the function or the model that you're deploying. The second and third ingredients being the types of inputs and outputs that you want to create. What this does is this goes ahead and this creates this little GUI here for you. And so this is a web-based GUI that's running. And what this allows you to do is this allows you to drag and drop in your own images into this machine learning model here. You can run the model and you can kind of get the predictions out, and they'll be displayed nice in this GUI. And the cool thing also is that Gradio ships with these intuitive tools to actually manipulate your input data as well. So you can see what happens, for example, if you adjust the brightness of your image and see how that affects the model's performance. So in this case, you can see that the original model, it predicts cancerous, but if you adjust the brightness of your image, then now all of a sudden it predicts benign. And so this is indicative of a problem potentially in your machine learning model where it's very sensitive to the lighting conditions. And so this is kind of cool because now you can share this with your collaborators, your colleagues, your end users, your customers, whoever it may be, and they can try out your model. They can potentially, identify issues with it if you share it with a quality testing team, for example, and they can give you feedback on how your model is doing. One thing that I mentioned before that I want to reiterate is that Gradio works everywhere where you can write Python. So it uses the standard Python interpreter, which means you can run it as a regular script, or you can run it inside a Jupyter notebook or Jupyter Lab, or inside a Colab notebook or Kaggle notebook. Wherever you write Python, you can run this and it works. Okay. Of course, that's just one example. There are lots of other kinds of demos that people have built with Gradio that you can build as well. So here we have something called Video GPT. What it does is it, just like the GPT style of models complete a sentence that you begin with, Video GPT completes a video based on the initial frames. So you pass in kind of a short video clip, and Video GPT tries to complete the subsequent frames. And here, naturally, what you want for the input is a video, so you can pass in a video here. And what you want for the output is also video, so you can pass that in as well. And people can put in their own videos, get predictions out. And again, it's just a very similar logic, just 3 lines of code, and everything just works fine. Right, we'll see one more example here. So this is a little bit more of a sophisticated example where you actually have multiple input parameters. And so you have some text, you have some steps, and you even have maybe an image, an optional image. And so what you can do is you can specify a whole list of inputs or a whole list of outputs, and Gradio will render that interface for you in this kind of intuitive way. All right. So the other kind of important thing that Gradio allows you to do is it allows you to share your machine learning models very easily. So there's, I talked about building a demo, but there's also, the other piece of it, which is sharing a demo to other people. Presumably, you're not building a demo for yourself, although sometimes you are, but sometimes, in most cases, you're building a demo to share with somebody else. And what Gradio does is with just one extra parameter, it changes, if you just specify share equals true here, it builds a public URL for your machine learning model, meaning that now anyone can you can just share this just like you share a Google link, a Google Drive link, and anyone can just open it up in their browser while the model continues to run locally. So you don't have to worry about deployment or Dockerization or any of those kind of, the hassle of any of that. Your model continues to run locally while someone else can access it, and whoever you share this link with can access it using their internet browser. And there are kind of advanced things like adding authentication if you want, and so on, that Gradio supports out of the box as well, but we won't get into for the sake of this talk. Okay. Yeah, so like I mentioned, this is very useful as it allows you to share your machine learning demos with a wide kind of group of people. One use case that we've seen, for example, is that machine learning developers who have built medical machine learning models, sharing it with doctors and clinics at multiple different locations. And what these clinicians can do is they can start using the model, and anytime that they see a problem, they can click a flag button. What that does is sends that data point back to the original user, the machine learning developer, and now that gets stored locally. So they have like a little database automatically that gets set up, and they can just go through that and see all of the different issues that their models are having at different locations. It's kind of nice. And then kind of the last piece that I think is very important as well is if you want to actually share, like build a permanent link to your model. Let's say you want to actually have this model uploaded and you want to be able to link to it from your portfolio page or your personal website or a blog. You can do that by uploading your Gradio demo to Hugging Face Spaces. So Hugging Face Spaces is this repository of machine learning demos. It can support all sorts of different machine learning apps, and in particular, it can support Gradio demos out of the box. And so if you just go on huggingface.co/spaces, you'll see this. You'll see the ability to create a new space and upload your Gradio demo, and Hugging Face takes care of the rest, hosting it, giving the resources, the computational resources necessary to run your machine learning model. All right. And then I'll end with several cool things that you can do is when with Gradio demos that are up on Hugging Face Spaces. So these are kind of this, you can think of it as additional motivation to put up your Gradio demo up on Spaces, or just kind of cool things that you can visit Hugging Face Spaces and kind of take a look at this. One cool thing is you can load Gradio demos very easily from Hugging Face Spaces. So for example, this is a space that somebody has built for removing the background. And if you just go on huggingface.co/spaces/ the username / the space name, you can visit this in your browser. And what you'll notice is that this is a cool space that allows you to drag and drop an image and get the background removed. So this is nice, but what if I want to run this with my webcam instead of dragging and dropping an image? You can easily tweak inputs and outputs and override them wherever it makes sense. And so I've done that here. I've caused it to kind of remove the background, but with my image instead, and you can see it works pretty well. You can also mix and match different demos together. So for example, I talked about a new summarization model earlier in my talk. There are also spaces that allow you to convert from English to German. And so, for example, I can easily put models in series here. So here I've put two models in series, a summarization model and a translation model. And what this allows me to do is it allows me to summarize a news article in German here. So you can see that here I've taken a summarization model, a English to German translation model. I've put them in series, and now I have one particular demo, one space that takes in my URL, and then it summarizes it, it converts it to German behind the scenes, and you can see the output here. Now this is cool because you can imagine mixing and matching all sorts of machine learning models, maybe something that captions images and converts it then to another language, for accessibility purposes. And so there's a lot of cool things that can be done here. In addition to putting models in series, you can also put them in parallel. And what that means is you can compare machine learning models really easily. So let's say there are 3 different translation models up on Spaces. You want to know which one is the best for you. You can just put them in parallel, put in one input, see the results from all of the machine learning spaces in one place, and say, okay, this is what I want. This is what works for me. Let me, fine tune this model, for example. Yeah, and you can do a lot more things. I talked about parallels, so that's kind of what's happening here. Is you can try different machine learning demos and put them in parallel, and you can see the output of these different ones here. I'm going to go ahead and move forward just for the sake of time. The last thing that I'll mention, and I'll close with this, is you've seen all of these different machine learning apps that people have built, and they've built machine learning apps for a lot of reasons. A lot of times it's for internal use cases. So for example, businesses, they want to be able to put their machine learning demos in front of customers, in front of colleagues, business teams, for example, or product management, people, or quality testing teams, for example. But it's really like I think we should be thinking much more broadly than that. Why build machine learning apps? Because fundamentally, it allows a ton of people to actually start using machine learning. Really, I think what's crazy is that if you build a machine learning application and you share it as a web demo, potentially, any of the 4.7 billion people connected to the internet now can start using your machine learning models, and that's really powerful. And I think that can really kind of change the way that we think about building these machine learning applications, the kinds of use cases that come to mind, and really, I think, encourage us all to think, in a very democratic way. How do we democratize the kind of stuff that we're building? With that, I'd like to close. I'd like to thank you all for listening to this talk. I really appreciate it. If any of this sounded interesting, you can try Gradio in under a minute, I would say. You can just pip install it. There's some hello world, getting started code. You can copy and paste it inside a Jupyter notebook or a Colab notebook or a Python file. And then when you run it, you'll see a GUI that pops up that you can try. And of course, there's a lot more that you can do that I've alluded to in this talk. But if you have more questions, visit our website, www.gradio.app. That's kind of the central place for documentation, for our Discord, and for all of the other things that might be useful. Again, thank you so much.